So today we're going to begin Unit 3. I've got the standards on the whiteboard over here. A couple of the understandings that I want you to kind of gain from this particular unit, especially this week. Understanding number 1, error is unavoidable when measuring physical properties, and a measurement is characterized by the precision and accuracy of the measurement. Understanding number 2, units and quantitative reasoning can guide mathematical manipulation and the solution of problems involving quantities. And then also understanding number 3, dimensions are included on technical drawings according to accepted practice and an established set of standards so as to convey size and location information about detailed parts and their features. So we'll kind of come back to those standards as we need to as we get into the lesson. But we're going to look at today the SI measurement system, and we're also going to look at the customary, U.S. customary system. And we'll get to that in a couple of moments as well. The International System of Units, also known as the SI system of units. This is really the modern form of the metric system. The abbreviation SI is from French System International de Units. And you see here on this chart that this is the most widely used system of measurement. The only industrialized nation that has not adopted the SI system is, of course, us in the U.S. And that's why we'll look at also the U.S. customary system in a few moments. But also notice that this particular system, the SI system of measurement, consists of 7 base units. I'm going to want you guys to know these 7 base units. You'll need to know that it has 7 base units. You'll need to know what those 7 base units are. You'll need to know their symbols, and you'll need to know exactly what they represent. For instance, meter, the symbol is M, that represents length. Kilogram, the symbol is kg, represents mass. Second, the symbol is S, represents time. Ampere, the symbol is A, represents electrical current. Kelvin, the symbol is K, represents thermodynamic temperature. Candela, the symbol is CD, represents luminous intensity. And then finally, mole, the symbol is MOL, and represents the amount of substance. I'll print this chart for you guys so that you don't have to write those down in your notes. I'll print these charts and hand them to you so that you can just insert them into your notebooks. You can also see this particular chart. I'll print this one as well. So all the charts, don't worry about writing those down. I will print them for you. This is often referred to as the metric scale. Prefixes indicate an integer power of 10. And you can look at these charts. I'm not going to read all that to you again. I'll hand you those charts, and you'll be able to refer to those charts as needed when you need to use them in the assignments. But you see that they are a power base of 10. These are all positive integers, powers of 10, and these on this side are all negative integers. You're going backwards from the beginning of the scale, and we'll talk more about that in the detail when we come to that. So what does all this mean? When you think about some common items, if you're wanting to think about this metric scale that we're going to look at, the SI scale, and you're wanting to begin to think about how can I use that on common everyday items. Think about the human hair, something that some of us don't have a lot of, but think about the human hair. If you were to measure this human hair, the thickness of that hair, which is what this represents, it would be 0.1 millimeters. What if you took 2 sheets of paper and put those 2 sheets of paper together and measured the thickness of those papers? It would be 0.2 millimeters. If you took an average paper clip and you wanted to get the diameter of that paper clip from this side to this side and made a diameter around that paper clip, it would be 0.8 millimeters. And when you look at some common objects like that, it ought to be able to help you to relate and understand it, this just a little bit better. So let's talk about recording measurements. Because when you record measurements, whether that be on a drawing or whether that be in an activity that we'll do in just a few moments, there are some rules or guidelines, if you will, to help you to better record the measurements correctly. First of all, a measurement always includes a value. What that means is the number. If it is going to be 2.00 millimeters, then the value would be that 2.00. A measurement also includes units. That would be the millimeters that you would put after that particular measurement, or whatever unit that we would include. The example I just gave is millimeters. The measurement always involves uncertainty. That leads us back to the understanding one of our standards. Remember I said error is always unavoidable when measuring physical properties. Now, to some of you that may sound a little strange, because when you think about measurements, you think in form of 1 inch or 12 inches, or in this case, when we're looking at the SI system, you're thinking of centimeters or millimeters. And you may say, well, if we use a ruler and we measure something and it's 5 centimeters, how is there error involved? The error comes in because when you begin to get smaller than the units that you're used to using, there's going to be an uncertainty at some point. An important part of this idea is knowing how far down you can go in a measurement without hitting that uncertainty. 5 centimeters is okay. But when you go to 5.01 or beyond that centimeters, then there's going to be some uncertainty. In fact, a measurement is only useful if a value is associated with the units and the uncertainty of the value is also understood. I'll explain that just a little more in just a moment when we look at a couple of examples. Another thing that I want you to understand when we're thinking of this idea of rules or guidelines is this. When it comes to scientists and engineers, they often use significant digits. Now, what is a significant digit? A significant digit would indicate the uncertainty of a measurement. For instance, significant digits are the digits in a decimal form, decimal number, that carry the meaning indicating the certainty of the value. All digits that you record for a measurement are considered significant. For instance, if you go back to my example of 2.0 centimeters, then both the 2, the point, and the 0, all that in decimal form, 2.0, would all be significant digits. What if your measurement, though, was 2.05, and I told you to round to the nearest tenth spot? You would obviously take that, and it would become 2.1, and the 2 and the 1 would be significant digits. Include all certain digits. The certain digits would be the 2 and the 1. When you get into, when you go into further measurements, when you go past the tens spot, you're going to have to understand that some things are going to become uncertain. In fact, you may even have to take an educated guess at what that is when you go beyond those certain numbers to an uncertain digit, an estimated digit, if you will. There are some general rules that I want you to kind of think about. And we're going to concentrate on measuring and recording linear length measurements in this particular presentation. But the techniques discussed apply to all types of measurements. We'll look at an example of a decimal scale instrument first, which would be a metric scale. And later we'll talk about a fraction scale, or ruler that is divided into fractions of inches. So thinking about these general rules. Digital instruments read and record all digits, including zeros, after the decimal point exactly as it is displayed. Let's say that we're going to pull out our digital scale out of the cabinet, and I tell you that I want you to measure something in ounces, for instance. And you set something on that scale, and it says that the weight of that is 5.001 ounces. All of those numbers, 5001, would all need to be written down and recorded because they would all be significant digits. and you want to write it exactly as it is displayed on the instrument that you are using. When you think about this decimal scaled instruments, you want to record all digits that you can certainly determine from the scale markings, and then you want to estimate one more digit. Again, we'll look at an example of that in just a moment. A typical metric scale often includes a 30+ centimeter graduated scale. When I say graduated scale, what that means is that it's broken down into increments, and we'll talk about that in more depth in just a moment. For instance, each centimeter is graduated or broken down into 10 millimeters. So if you look at this scale that's given to us here, when you think of your big numbers, your 0, your 1, your 2, your 3, and so forth, in between each one of those numbers, there would be 10 slashes. Those slashes represent millimeters. And there are going to be 10 of those, and so 10 millimeters equals 1 centimeter. And in between each number, you're going to have 10 of those markings. And you're going to get a chance in just a moment to read this and look at a couple of examples. As we go through this particular PowerPoint, it's going to break it down for you and show you what I just said by putting some arrows here. I just told you that the slashes that were between 0 and 1, or 1 and 2, or 3 and 4, and so forth, all of those slashes would be millimeters. And I just told you that there are 10. It says here the millimeter is the smallest increment found on a typical metric scale. The next larger marking on a metric scale shows 5 millimeters, because if you notice, that is the halfway point between 0 and 1. So you can count your slashes: 1, 2, 3, 4, 5 millimeters, 6, 7, 8, 9, 10 millimeters equals 1 centimeter. So you've got all of your slashes, your 10 slashes, but the one in the middle, if you notice, is a little longer. That tells you that you're in the middle. That's 5 millimeters. The largest marking on a metric scale represents centimeters, and that marking will always have a number beside it: 1, 2, 3, 4, and so forth. And they are the only markings on a metric scale that has numbers, so you know that those represents centimeters. Okay. With all that being said, I want you to, I advanced one slide too many, sorry. I want you to look at this rectangle that's in blue here. And I want you to think about how long you think that rectangle is. Now, it would be easy if this rectangle stopped at 4 centimeters. But notice that it doesn't. It's in between. So you're going to have to do some counting of those slashes and decide exactly how long that is. Let's look just a little closer and zoom in just a little bit. So as we see the red box that's zooming in just a little bit for us, this box lets us know that this measurement is between 3 and 5 inches. So we know that it's more than 3. We know that it's less than 4. So we know that we have a certain number here. Let's zoom in just a little bit more. Again, our certain number is going to be this 3 centimeter mark. But it's more than 3 and less than 4. So we've got to, again, count up those slashes to determine exactly how long this rectangle is. Because the scale is incremented in millimeters, or divided into millimeters, you can also be certain that the measurement is between 3.8 and 3.9. Here's what I mean by that. Notice this. There's your 3 and your 4 mark. If you count these millimeters, 1, 2, 3, 4, 5, 6, 7, there's 8. It's longer than 8. And there's 9. It's shorter than 9, as you can see by those arrows. So we know that we can be certain that this measurement is between 3.8 centimeters and 3.9 centimeters. But let's click one more time and look at this. So how long is the rectangle? In fact, I'm going to go back one slide and let you look at that zoomed in just a little bit. You've got to determine if the edge of that rectangle, is it directly in the center of 3.8 or 3.9? Here's where this standard comes into play of error is unavoidable. Because you're having to make an educated guess. Is this in the center? Or is it closer to the 8? Or is it closer to the 9? For instance, in this particular case, it looks as though this is exactly in the center. So we could say that this measurement is 3.84, or even I would accept 3.85 centimeters, because remember, error is unavoidable when you're getting down into small numbers such as this. The 3 is a certain number, the 8 is a certain number, the 4 is an uncertain number, because we had to take an educated guess. Again, if you would have put 3.85, I would have accepted that as well. Now, if you would have put 3.89, I would probably tell you to look a little closer, because that box is not right on the edge of that 9 millimeter mark. Again, it looks like it's in the middle. Hopefully that makes a little sense to you. And what I just said is here on the screen, that the 3 and the 8 are certain numbers, and the 4 is an uncertain number. Okay, your turn once again. I want you to think about this. Before I ask you what the measurement is of this rectangle, I want you to tell me how many significant digits are needed in this. Look at it for just a moment. I'm going to zoom in, put a rectangle or a box around it. We'll zoom in one more time. I gave you the answer. My remote's a little touchy today. How many significant digits are necessary? I didn't say how many certain numbers. I said how many significant digits are necessary.
3.
3. All right, that is correct. Here's your answer. 6.33 centimeters. Now, if I were to ask you how many certain numbers are in that, that would not be the same as significant digits. Certain numbers would be 2. You're correct. Because you got your 6 and your first 3. We know that it's past 6 centimeters. 1, 2, 3. We know that it's past that 3, so that's a certain number. And it's just past it. It's less than 4, but just past the 3. So your uncertain number would be the 3. But the significant digits, all of them are necessary. That's what significant digits mean. So there's 3 significant digits, there's 2 certain numbers, and 1 uncertain number. And that tells you exactly what I just said. All right. Before we get into this, this is going to be your activity for this particular lesson in 3.1a, linear measurement with the metric units. And you guys are about to go through and do this for practice. But before I get there, I want to go through the PowerPoint for the next unit, or the next part of this unit. So allow me to get into it.